Okay, guys, so today we're on Unit 2, Lesson 5 of the Algebra 1 notes. And again, so now we finished up the halfway point yesterday. And so today we're going to focus on slope moving forward for the rest of this unit. So our objectives today is to be able to find the slope of a line. And then we're going to be able to graph and write lines in slope-intercept form. So a little bit of history for you. The word slope and the letter M have a history in French. And René Descartes, in March of 1596, came up with a hypothesis about the word slope, and he called it monter, and that meant to climb. And so that's why a lot of times in the equation y equals mx plus b, you see the letter M standing for the slope. As a quick review, the slope is the change in y over the change over x. And we also call that the rate of change. In symbols, the slope formula is y minus y over x minus x. And the way that I always tell students to remember that when we're looking at a coordinate grid is rise, so up and down, over run, left to right. So your y's over your x's. When you do slope, you are getting a fraction that may or may not reduce. So let's practice using the formula real quick. And this should be a review. But if I'm going to do the slope for this one, I'm going to do 4 minus 1 over 5 minus 2. I get 3 over 3, and that's equal to 1. Now, the question I always get is, Mr. Simmons, does it matter which order I go in? Like, you notice I did 4 minus 1 and then 5 minus 2, and my answer is always no. Because if I were to do 1 minus 4 and 2 minus 5, I would get negative 3 over negative 3. And that's also equal to 1. And so, it doesn't matter which way you go as long as you go the same way both times. Alright. A couple other things about slope. Make sure you remember how to subtract negatives. So I get 4 over negative 7 for this one. You're always going to move a negative to the top. The slope is negative 4 over 7. Also remember, if they cancel out and you get a 0 on the bottom, this is what we call an undefined slope. If they cancel out and you get a 0 on the top, this is what we call zero slope. Okay. You can also find slope given a graph. Remember, this is a positive slope, this is a negative slope, so when your answer is done, you should have positive or negative. The key is to find 2 points. So I found 2 points. I found negative 1. I'm sorry, I found negative 1. I'm going to find this one actually. Negative 1, negative 3, and 5, 0. And I could do the slope formula from there. 0 minus negative 3 over negative 5 minus negative 1. Oh, I'm sorry, it's positive 5. 5 minus negative 1. I get 3 over 6, which is equal to 1/2. For this problem, I get negative 1, 1, and then I get 0, 3. I get 1, 1, and then 0, negative 3. So I get negative 3 minus 1 over 0 minus negative 1. I get negative 4 over 1, which is equal to negative 4. So just a reminder on how to find slope of a line. As we just talked about, there are 4 types of slope. A positive slope goes like this. A negative slope goes like this. A zero slope goes like this. And an undefined slope goes as such. And here's the way I always remember the slopes. If I'm on skis, it takes a lot of energy to go up, not that much energy to go down, no energy to go across, and if I'm going to be on this kind of slope, I'm going to die. So that's an undefined slope. You can actually find the coordinates if you know the slope. So if I were to set up this equation before I knew what the slope was, I would say y minus 2 over 7 minus 6. If I know the slope, I can create a proportion, which is what we worked on in the last class. And so if I create a proportion, I can solve this. I just cross multiply. 3 times 7 minus 6 is 3, because 7 minus 6 is 1. And 3 is equal to y minus 2. And so then I can add 2, and I know that y is equal to 5. So that's just a quick review of everything that you could possibly be faced with slope. Why do we use slope? That's the important thing. We use slope because we know that lines are written in slope-intercept form. Okay? And so a linear equation that we see a lot is y equals mxb. And this is what we call the slope-intercept form, where m is the slope and b is the y-intercept. Now, remember, b can be positive or negative. The slope can be positive or negative. But let's look at this, for example, of y is equal to 2x plus 7. If I was going to plot 2x plus 7 on this graph, I would know that the slope was 2 and the y-intercept was 7. This is the y-axis. I'm going to say 7 is roughly here. The slope is 2, so I'm going to go up 2 over 1, or left 1 down 2. And I essentially create a line where I know that the b value is where the line crosses the y-axis, and the m value describes the slope. So what I want you to do is I want you to look at this slide and go ahead and for the top 4, circle the slope and underline the y-intercept. And then in the bottom, I want you to write an equation if I give you the slope and the y-intercept. So go ahead and pause the video and attempt this slide. Okay, so hopefully you took a minute and answered those 8 questions. I want to talk about a couple of these. Notice how I didn't underline anything in this one, and I had to rewrite it. The slope is actually 1 over 5, because remember, we've talked about anything in front of an x is just 1. And there is no y-intercept in this. In this one, there is no slope. It's a flat line. So then when you were writing these equations, I gave you 2 equations where you had to write them out with all the information. But then I had 2 equations where I took something out. Y equals 0x plus 5, we know we don't have to write the 0, so we just put a 5. Y equals negative 2/3 x, we don't have to write plus 0, so we just leave it alone. These are the final correct answers for these 2. Alright, so again, what 2 things do you need to write an equation in slope-intercept form? Well, the first thing you need is to find the slope. Given this problem, if I put my pencil there and there, I can easily find the slope. I can either do it by counting the blocks and doing the slope that way, or I can do it by actually just placing the points and using the formula. I'm going to do it by counting the blocks. It's up 1 over 2, so the slope is 1/2. The second thing to do is find the y-intercept. The y-intercept is -2. So once I have the slope and the y-intercept, I can go ahead and write the equation. So I'm going to write y equals 1/2 x plus -2. I could have also written it y equals 1/2 x minus 2. I would have done the same thing. Just like you can pull an equation from a line, sometimes you have to graph an equation given the line. So again, step 1, slope. Step 2, y-intercept. Slope is 3, y-intercept is 1. Step 3 is graph. If the y-intercept is 1 and the slope is 3, we're going to go up 3 over 1. I can't go up 3 again, so I'm going to go left 1, down 3, and then I graph my line. Sometimes you might have to reduce before you can do that. You have to get it into y equals first. So in order to do that, here I do -9y. I'm going to add 6x to both sides. Before I can move on, I have to divide by -9. 6 divided by -9 is -2/3. -18 divided by 9, -9 is +2. So I have my slope, I have my y-intercept. Now, this one is down 2 over 3. Down 2 over 3. Down 2 over 3. Notice that I make 3 points before I graph my line. When you guys work on the problems in class, you will be doing the same thing. Special graphs. Remember, if you get a line and it says x is equal to 3, you go to where x is equal to 3 and you're creating a vertical line. The slope here is undefined. If you go to where y is equal to -1, you put a point, you're creating a horizontal line. And the slope is equal to 0. This covers all of the things that you can face when you have to do slope. Make sure you look over these 3 pieces about how to write an equation given the slope and the y-intercept, how to graph an equation given the slope and the y-intercept, and how to change an equation so that it is in slope-intercept form. Go back and watch those to make sure you're clear on what you're supposed to do. Our work today will focus on each of these individually, so make sure you bring the notes because they'll assist you in the work problems.